Hi, everybody. How you doing tonight? I always like to ask questions, and I know you can't really answer, so that's all right. I'm just kind of used to having a live audience. My name is Rick Alling, and I am the director of the Marston Exploration Theater. That is associated with the School of Earth and Space Exploration at Arizona State University. We have facilities on the main campus in Tempe, and our building, we call it ISTV4. It's kind of a funny name. It includes a space where the public can come engage with us. So there's gallery spaces, there's the theater where you can see shows, usually twice a week. We're closed. Everybody's closed, and it's going to be a little while before ASU starts expecting or having visitors back on campus where we can do the one-on-ones and meet you guys. And we look really forward to that time when we can get back to normal. But until then, my staff and I and the colleagues and the people that are associated with our community outreach group, we thought that what we could do is just kind of do these virtual night skies. So we're every other Wednesday night. We started with an experiment in May and formally in early June, and we've been going ever since. We've been kind of testing the audience as we go, and we know we always have a handful of people that watch these every other week. Thank you and welcome back, and I'm glad you're attending tonight as well. And then I know that we always have new visitors as well. And so welcome. I hope you like what we do. These are very, very low key. This is just sort of about sort of the astronomy that is in your backyard. This is about things that you can look for, things that are going on in space that are part of everyday life. And that's what we're trying to get to, especially the idea that we can share things with you on screen tonight. And then right after the program, you can go out and try to find some stuff. You can actually go out in your night sky and try to find things. So that's the idea behind this particular program and where it started and how it works. I have two colleagues with me. Kim Baptista is the one that has been communicating with you. So she's the one that gets these webinars organized and started. It is her tools that are making the webinar happen. And she's the communicator amongst us. So she'll be sending you a survey after the program tonight so that you can kind of talk about, anything you want to see or anything you think we need to change. We want to hear about it, and you'll get a survey in a day or two, so you can do that with us. Meg Hufford is my colleague on the ground. She and I, she's on tonight as well. She and I are the ones that kind of are the front people that meet the public at the School of Earth and Space Exploration. We are so there's faculty. We are a research institution, so there's laboratories and people working in all these laboratories. And Meg and I sort of head up that part of the organization that reach the general public, you that can come visit us on campus. And so she's here tonight too. We also believe we have many teachers. We've been sort of courting teachers. We're going to figure out ways to get into the classroom virtually as we go forward. So if you have school-age kids and if you sort of have communication with their teachers, please have them contact us, because we have ways of doing this and get right into the K-12 schools during their classroom day and sort of break up the monotony of their Zoom instruction as much as we can. So that's happening. And maybe there are many students. So if you are a student and you're interested in astronomy and kind of want to learn some things about the night sky, welcome. And I hope you're here with your family. And I hope the audiences include many multi-generational groups. There are 3 students with us tonight. Spruthi Kasari is actually on the team here, and you'll meet her a little later. She's going to help with some question and answers, and she's got a little presentation that you might have heard on the news, something about Venus and Venus's atmosphere, and she's going to share that with you. Alex Blanche is here, and he is also going to help with questions and answers, and some other news going on. I think we all saw this new amazing image from the Hubble Space Telescope, and he's going to share what he learned about that with us tonight. And then Alicia Hyatt has been with the Marston Theater for years and years, and she's here to keep us organized and keep things going, and she'll be sort of managing some of the question and answers as well. So this is This is sort of how we get started. And what I'm going to do tonight, let me just give you the rundown. I'm going to give you some night sky highlights. We're going to go to a night sky view. In fact, I'm going to try to not be distracted and share a different screen over here so you can see how this works. I'm going to point out some things that are going on, some constellations and some planets in the night sky, and then we'll kind of we'll work on that for a moment. And then once that is complete, I'm going to kind of walk you through the new moon. There's a new moon coming, not tonight, but tomorrow night. Moon is also going to trigger a pretty amazing cultural celebration. We call it Rosh Hashanah in the Jewish culture, and all of that works together. I'm going to do that. I'm going to talk about the the autumnal equinox. The fall equinox is coming up. That's when we will have an equal day and night. That is when the sun will pass from the northern part of the equator, across the equator, down towards the southern part of the sky. That's we're celebrating in Phoenix because we're tired of the heat, and cooler temps are coming, and all of that has to do with that, the relationship with the sun and where it is in the sky. We'll talk about that tonight. And then I just want to give you an update on the planets. Jupiter, Saturn, and Mars are spectacular. And they're going to continue to be spectacular for the next several weeks into early December. So I just want to get it. I'm just going to continue to show updates and show where they are and what to look for and how that works in the night sky. On the screen here, you have something. I actually have to just go away for one quick second. I'm sorry. I put my pen on the charger. I'll be right back. Goofy me, I have never done that before. Sorry about that. So what you're looking at is it's a little screen on my iPad, and I can manipulate it. I can move it around a little bit, and we can look at the different horizons, and we can see what's up in the night sky. And what I usually do is I also sort of use this as a little writing pad. Kind of just sort of get a little virtual screen in front of us and sketch on it. I just draw on it. And so first, to start with, I want to point out that this is essentially the western part of the sky. Every single thing within the green circle that you see on the screen is above the horizon right now. Everything in that circle is viewable if you had dark enough skies. And so what I'm going to do is I'm going to point out the highlights. You can sort of just kind of squint your eyes. You can see the bright ones. I'll show you what those are, and then show you kind of what to go out and look for in the night sky. And we'll sort of give you some easies and some mediums and some challenges tonight as we go forward. So so the western part of the sky is over towards that part of the screen. The eastern part of the sky is over here. You see Mars is that red dot just kind of coming above the eastern horizon. That's kind of cool. North is this way, south is this way. And so as I go through this, I'm just going to sketch and draw and kind of fill in the whole screen, and then we'll go visit some of these horizons, and we'll look a little closer at what you can actually see sort of above the horizon. If you don't mind, we'll do it that way. I always love to start with the Big Dipper, and you can see it in this part of the sky. It is towards the north. When we first started this program, the Big Dipper kind of looked exactly like this. It was in this part of the sky, and it was big and bright, and the tail of the Big Dipper pointed in this direction. That's how we started our little adventure about 3 months ago. Now that's not the case anymore. So we are, oops, object eraser. Pixel eraser. I'm just going to get rid of this and come back again. That's how we started the program, but things have moved along. The two stars at the end of the Dipper Bowl, as you probably already know, point towards the North Star, Polaris. And all of that is visible tonight. So after the program tonight, I have this clock set on this particular screen set for 8:45. So if you can stay up that late, then you'll see Mars coming up. If you go any earlier than that, everything but Mars will be above the horizon. So that's it. We also learned early in our explorations of the night sky earlier in the summer that the Dipper handle kind of arcs over here towards a very, very bright star called Arcturus. It looks really red in the sky tonight. And so I encourage you to go out and look at it, look towards the western horizon. You'll see it. In fact, if you wait long enough, you can sort of just get there at exactly the right time. You'll see a really orangish red Arcturus in the west, and it will be setting within a couple hours, and a reddish orangish Mars in the east, and it will be sort of rising and get brighter in the night sky. So you see sort of both of those things. We also have talked a little bit, and this is very easy. This is one of the easiest things to find in the sky tonight, is what we call the summer triangle. This is made up of three very bright stars. Vega is the brightest, and Vega is almost directly over your head at 8:30 after the program. Go out, and if you want to know where to look, look straight up, just exactly over your head. That bright object will be the star Vega. And then see if you can find, trailing a little bit towards the east is a bright star called Deneb, and a bright star down here called Altair. And the three of them together make an isosceles triangle. That's called an asterism, when there's like a little cluster of something that sort of makes a shape in the sky. The asterism is a triangle. It's called the summer triangle, and it's just exactly over your head at your best viewing time, which is about 8:30 or 9 tonight. So those would be good things to look for. Two planets, the brightest one. In fact, I just went out before the show tonight, just a couple of minutes before 7 o'clock, and yep, I could see Jupiter. It still was a little bit of twilight outside, but Jupiter is a very bright star. Now I'm kind of looking towards the south. So you sort of have the south horizon in view here, and you're looking up just above, about 30 degrees above the horizon, Jupiter. And the dimmer one is also an impressive planet called Saturn. A couple of other things to look for in the sky, and this next one is going to be kind of a challenge, and so I'm going to sketch it, and then we're going to go to the eastern horizon, and I'll show you what to look for, because it'll come into play more and more as we do these programs into October and November. But there is almost a perfect square in this part of the sky. We call it the Great Square. I sort of have one of my things off. The reason it's a bit of a challenge is that the stars that make up the square are much dimmer than the stars that make up the triangle, are much dimmer than the one we called Arcturus. They're much dimmer than the stars of the Big Dipper. So it's going to be a little bit more of a challenge, but it rides just a little bit above Mars, which is just coming up over the horizon at the same time. One more star I'm going to show you, and it's also a bit of a challenge. So if you can see the square, you can certainly see this one right down here. It's a star called Fomalhaut. Fomalhaut is the alpha star, the brightest star of a constellation that is associated with fishes, not Pisces, but it's a constellation called Pisces Austrinus, which means southern fishes. It never gets very high in the sky. In fact, it's an example of a star that just sort of arcs across the sky like this. This is all we get to see of it. It never gets higher than this particular point above the horizon. It's visible this time of year. It's an important star scientifically because it's one of the first stars where we actually saw exoplanets, where we've determined that it actually has orbiting planets around itself. And we're going to hear more about that in the later programs too. I think I'm going to devote at least half of an hour program soon to just exoplanets and exoplanet research because it's moving so fast. Okay, let's see. I promised I'm going to head for the east. Let me get rid of this. I'm going to take you to the eastern part of the horizon. Let's make the horizon flat like that. And what you can see is, of course, the very, very bright thing just rising above the eastern horizon, almost at the eastern cardinal point, is the planet Mars. I was watching Mars the other day, and I noticed that it was really especially red. Mars, when you usually look at it during normal conditions, it's kind of got a little rust color to it. You definitely reddish or orangish or reddish, or definitely kind of in that part of the spectrum, but not just like blood red. But the other night it really was. And it turns out that is, I think I figured out, that's because of all the fires we have going on. There is a lot of smoky haze in the sky. It's there, it's with us. Sometimes you can see it, sometimes you can't, but it is actually changing the color of things. If you've watched the sunrise or the sunset and see that really, really reddish ball as it's coming up over the horizon or just about to set, that's because of all the smoke in the air from the California fires and some of the Arizona fires. So important to kind of keep those things in mind. The atmospheric conditions actually have an impact on how you see the stars in the sky. Remember, let me screenshot real quick. Remember I was talking about, so here's Mars just above the horizon. There's that great square I was talking about. 4 stars that make up almost a perfect square. We call it the Great Square. Sometimes we call it Mariner's Square because it has some history in finding our way around the planet for sailors as they're sailing in the oceans. It's also part of a bigger constellation called Pegasus. So the head of that big horse kind of goes out this way. And legs of the horse kind of go down this way and back this way. And so I sort of butchered his body here a little bit. But anyway, the constellation is called Pegasus. Embedded in that constellation, the body of that horse is almost perfect square. And the other thing that's a little bit unnatural about the square, or something that's kind of interesting to look at, is it's almost devoid of stars inside. I won't say completely, but when you can find the outside stars, the perimeter of the square, try to look inside the box and see if you can see anything. And it just happens to be in a very dark part of the sky where it's kind of a little bit devoid of stars. Later in our programming in October and November, we're also going to talk a lot about Andromeda, which is a constellation that sort of shares this particular part of Pegasus. But Andromeda is very, very important to us because in this part of the sky is a galaxy, the Andromeda galaxy, and it's too early to start looking for it right now, too close to the horizon. But in late October and early November, we're absolutely going to watch Andromeda. We're going to watch that scene and watch what happens. Okay, wanted to show you that. That's the eastern part of the sky. Let's flip around to the south. I already talked about Fomalhaut. And so if you're looking directly south, what you're going to find is screenshot. What you're going to find is Fomalhaut is the brightest object just a little bit to your left. It's going to be towards the eastern part of the sky. And if you watch long enough over time, in the next couple of weeks and in the next couple of hours, both of them kind of serve the same purpose, Fomalhaut will rise into the sky. It only gets, like I said before, just about this high above the southern horizon, and then it goes back down again. It's it's the brightest star in the most southern part of our sky. So it's kind of fun to look for there. And then I'm going to sort of talk a little bit more about this at the end of our program, but right here above the southern horizon, absolutely you will be able to see these objects tonight. It is Jupiter and Saturn, absolutely in the night sky. And so just before, I'm sort of running out of time in this section, but just kind of, again, you can start at any horizon and just look up high in the sky, and that's where you'll find that triangle. Does everybody notice how there's sort of this shading of sort of the Milky Way is kind of going through the system here? You won't see that in the city of Phoenix. That actually needs darker skies than we have, and it needs clearer skies than we have. We're at the tail end of our monsoons, so there's still a lot of moisture in the sky. We have a lot of city lights, and that smoke I was talking about, that's an added influence on our atmosphere. So you won't necessarily see that, but if you can identify a constellation here called Cygnus, actually let me erase some stuff real quick, just so I can kind of show this to you. Erase, 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 erase. One of the corners of the triangle is a star called Deneb, and it is right here. And Cygnus is a swan, has this really beautiful wingspan that comes out this way, another wingspan that goes out that way. The tail of the swan encompasses this back area and is part of Deneb. And then this really long, beautiful, graceful neck that comes out in this direction and then goes back there. I always like sort of finding the swan because when I can find it, I know that it is flying along the path of the Milky Way galaxy. Even though I can't see the Milky Way, that cloudy material, stellar material that's in the night sky, I know it's there. I know where to look. And Cygnus is how I find it this time of year and kind of organize how to look for this bright star in the sky. That's it for just sort of things that I've identified in the sky to show you tonight. Over towards the west, this is that star Arcturus. The orange star just above and to the right of the west is the Arcturus star. We're about to lose those. Those are setting. And Arcturus is a star that happens during the agricultural seasons, when we plant and when we harvest. It starts in the sky in March when it's time to start the harvest. It sets in the sky in September and October. We'll lose it into the sun's glare pretty soon when it's time to bring the crops in. It's going to get ready for the winter. So it's one of those signal stars for that. You'll see just below the horizon over there is the sun and the moon. And that's what I want to talk to you next. I'm going to switch to a different computer because I have sort of a horizon and a moonshot, and I'm going to be able to show you some things to look for. So I'm going to, if I can really quickly, I'm going to unshare this particular screen. If I can do this and talk at the same time, life will be really good. And then I'm actually going to go over to another computer and share this screen. I know it's all about technology, isn't it? You should be able to see essentially the house across the street. There's some cars over there parked in the driveway. And this is a little bit fakey because I have the sun and the moon above the horizon and the stars are in the sky. So I don't know, a little bit fakey, but you can sort of like see it. And I just wanted to show you this. If you can see, the moon is right here. And it's a new moon. So the moon is very, very close to us. It's in front of the sun and it's moving. Well, I'll show you which way it's moving. So this is how they looked tonight. And just watch what happens. If I go ahead and allow this scene to set, you'll see the sun and the moon go down together. Just below, they're going to go behind the house and we're going to lose them. And that means you're not going to see the moon. That's basically the last slivers of a moon before it becomes a new moon. Let me back up a little bit, bring the scene back, and let me show you the same thing tomorrow night. And let's have a little mind discussion here as to whether we'll be able to see the moon tomorrow. So I'm going to press the 1 day button. Here it goes. Watch closely. And did you see what happened? The moon moved from just exactly to the right of the sun to above and past the sun. I'll go backwards. That's tonight. That was the relationship sun-moon. And this is tomorrow. In between, somewhere around, I wrote it down, 4 o'clock in the morning tonight, it's going to be a new moon. That's when it's actually passing as close to the sun as it can get in this particular orbit. By the time we view it tomorrow night, it will have moved past the sun and then some. So let the sun go behind the house again. This time, the moon is going to stay behind a little bit. And this is what I wanted to talk about. I don't know if there's anybody of the Jewish faith that's watching the program tonight, but one of the things I've always found fascinating is how we incorporate astronomical phenomena into our calendars, into our culture, and into all of this stuff. The new moon is very, very important to that culture. Every month, it's sort of it's a kind of the signaling of a new moon. They call it the head of the month, is sort of their name for this particular phenomenon. But the one coming up tomorrow night actually has another trigger. It's called the head of the year, which is pronounced Rosh Hashanah. You guys have probably heard about that celebration. Even if you're not of the Jewish faith, you know, you have friends, you know people, you know that's one of the most important celebrations in the Jewish calendar. And it is all triggered starting tomorrow night. In some of my reading and research in the background, I kind of checked into some of this, and I found something really, really fascinating. In the Jewish culture, especially historically, in what they call the Second Temple in Jerusalem, it was important to have the new moon start with at least two witnesses. They found in scripture that the moon had to be witnessed. Somebody had to see it. It couldn't be necessarily predicted like we can do today. We know exactly where the moon is and exactly when it's a new moon, and we can predict exactly when we're going to be able to see it again. In the faith from before, that wasn't good enough. Somebody had to see it. And so they would hold essentially a tribunal on the 29th day of every lunation, and people from townsfolk and people from the countryside, people would come forward and offer to be a witness that they saw the moon the last night. And if they could verify that that's true, and they had to have two witnesses, then that would trigger the new month. It would be pronounced for the next day. So in this particular new moon, tomorrow is what we call the new moon, and Friday is the beginning of the celebration of Rosh Hashanah, the head of the year. And so this is really sort of a very special one. Here's my challenge to you guys, and here's what I'm going to do. I'm going to go out at, let's see, what time is it right now? On my screen, that is 6:30 tomorrow evening. It won't be that dark. The sun is just below the houses, so it will be twilight, but the moon will be right there. And let's just see if we can do that. Let's stand there and look at the western horizon and see if we can see that little tiny sliver of a moon tomorrow at about 6:30. Watch for it. And then what we can do is basically stand in the footsteps of people that come 3,000 years before us, that have been actually viewing this same scene, and how meaningful it was to them as a sort of a beginnings. Rosh Hashanah is about repentance. Rosh Hashanah is about review. Rosh Hashanah is about sort of kind of looking back and moving forward at the same time. It's one of those snapshot times where we can do that. And so I'm going to end this particular section with that. Your challenge is to join me out in the outside tomorrow night, 6:30. Look directly to the west. You might not have Marcine's house there, but I do. And let's just see if we can see it. Let's see if we can find that new moon. And then if I just add a couple more days, of course, it's just going to get higher in the sky, and you'll start to see it sort of like turn into a little sliver. And over the next several days, it'll just keep rising and rising. I'm going to take a little break. I'm going to close out my particular sort of this little section. I'm going to go to a question and answer session with some of our student team. And thanks for listening. I'll be back and we'll sort of show you some things about the equinox in the next couple of minutes. Thanks.
All right, thank you, Rick. What we're gonna do now is we're gonna go ahead and start with some polls. So we're gonna go ahead and launch our first polls. And question number 1 says, have you visited Marston Exploration, the Marston Exploration Theater, or the Scientific Gallery at ASU? So yes or no, let us know if you've been here or if you've seen us before. Yeah, go ahead and let us know. Number 2, how many times a year is the amount of daytime and nighttime equal? So we have 4, 12, 2, or 1. So go ahead and cast your votes there. And then our third and final question for this poll is, which of these stars is a part of the summer triangle? Altair, Deneb, Vega, or all of the above? So go ahead and cast your votes. And while you're doing that, I'm gonna flip things over to Spoo to go ahead and take some questions.
Right, thanks, Alicia. So the question we have here is, why is Mars red? That's a very good question. It's a fundamental question. So Mars is red because most of the rocks on Mars are made from iron. And just like your bikes, when iron is exposed to the outdoors, it rusts. And the rust is reddish in color. So same thing happened with rocks on Mars in ancient times. They were all exposed to a lot of oxygen, which rusted the rocks. And these rocks are subjected to weathering because of strong winds, and the rusty dust kind of is suspended in Mars's atmosphere. This gives Mars's atmosphere like a pinkish hue. So from such a great distance, we tend to see Mars as a red planet. This is probably why Mars gets its color because it has a lot of rocks made of iron oxide, and it gives it a red color and a red dust. Okay, so back to you, Alicia. Let's end the polls.
Awesome. Thank you so much. We're going to go ahead and end the polls. So question number 1 said, have you visited the Marston Exploration Theater or this gallery or the Scientific Gallery at ASU? And most of you have not visited us. And so when we reopen fully, I highly encourage you guys to stop by and come see us in person when it's safe. But yeah, happy to have you guys virtually. Number 2, how many times a year is the amount of daytime and nighttime equal? And so most of us at 68% got this right. That is 2. So yep, 2 times a year. Great job. And then our third and final question for this poll is, which of these stars is a part of the summer triangle? And 77% of us got this right. It's all of the above: Altair, Deneb, and Vega. So great job, you guys. And with that being said, I'm going to pass things back to Rick to keep our show going.
Thank you very, very much. I'm just having just a slight little baby technical problem here. Let me just see if I can get things set for you. Wanted to specifically show you essentially sort of the all the conditions that are going to exist to make a one second here. I'm just going to have to concentrate a second on the position of the sky. So the fall equinox is coming. We call it the Autumnal Equinox, and it will be here on September the 22nd. And it will actually happen at about 6:30 in the morning. So we can be pretty expensive. I'm sorry, not expensive. We can be pretty exact about when that particular thing is going to happen. Hang on one second. I just have to do one quick setting here. I think I can make this happen. And there we go. There's that one. And there's the ecliptic. And there's the equator. So what I'm going to do is I'm going to share screen again. And I'm going to try to organize this so it makes a little bit of sense. What you're looking at here is 2 sort of lines in the sky. And one of them is the equator of the Earth, as you would see it projected out into space. That's the green one with the numbers 5, 6, 7, 8, 9. And the other one is the ecliptic. That is actually the pathway of the, let me sort of just do one more thing here. Sorry about this. I thought I had enough time while we were doing that little break to get everything set up. So that is the pathway of the sun, and you can see that it's marked in months. So if I just move ahead a little bit, sort of in time here, you'll start to get a sense of how this works. I know we don't necessarily think about the equator of the Earth projected into space very often, but that's essentially what's going on. That's what we're seeing here. So just think of that. I think everybody has seen a globe before, right? It has the equator around the waist of the globe. If you just take that ring and just expand and expand, just take it way out into space, it defines for us a celestial equator. And there are stars above it, and there are stars below it. And the Earth spins underneath that. So essentially the equator stays aligned with the equatorial or the star equator at the same time. The reason there are numbers instead of degree markings is that we mark the equator in what we call hours of right ascension. So that full circle, that green circle, if we followed it completely around, all the way around the path here, it would go from 0 to 24 and then start at 0 again and move to 24. You see that actually the equator is at an hour angle of 12 right here. In this part of the sky, and that means that we are exactly opposite the vernal equinox. The vernal equinox, when the sun is moving from the southern part of the sky to the northern part of the sky and crossing that equator, is what we sort of define as the beginning of an astronomical year. And that used to have cultural ramifications before. Of course, now our new year is January 1st. Before, it was always the first day of spring. And this is what brought that forward and why that works. So this is sort of part of what I want to show you. You can see that the sun is now sort of moved forward to next Saturday. I can actually sort of like, let me just go back to today, and I'll show you where the sun is tonight. You'll sort of see it move on the screen. Oop, and there's the moon, remember that? So there's the sun and the moon, and you can tell that this is counting. Here's the beginning of September, 10 days, 11, 12, 13, 14th, 15th, I think is today. No, 16th is today. And if I go forward just one day at a time, you'll see that the sun will move like just one little tick mark. There goes another one. There goes another one. There goes another one. And so I'm just going to move forward until between the days of the 21st and the 22nd. And if you're watching closely, you can see what happens is that the sun, following its path through space, actually just crossed the equator, and it's kind of moving down, and towards October, it'll get lower and lower and lower in the sky below our equator. And then of course, towards December, it'll become, we'll be looking forward to the winter solstice and all that. If my machine here is going to behave for me, which I sort of expect it probably will, I'm going to turn on some artwork here. These are constellations that we have been talking about since we started this program. You can see Leo the lion is sort of the one sort of like with his head over towards August. Virgo is where the sun is right now. Her head is towards the tail of the lion, and she stretches across the sky as you go. And then if I move a little bit further, you can see Libra. Oops, wrong direction. If I move a little bit further through space in this direction, you'll see, whoa, I didn't stop it in time. Sorry about that. Let me keep going, going. I moved all the way to the equinox in the spring. Let me see if I can get this particular demonstration a little bit higher in the sky, if I can do that. There's that. Hang on one second. Should be able to pitch a little bit. Hang on one second. Sorry about that. With all the rehearsal we do, we still didn't have it exactly right today. So that's all right. Let me kind of move back over here. What I kind of wanted to point out though, and I just moved too far too fast in order to do it, is that where that cross happens, where the line of the ecliptic crosses the equator, that's called a node. And when the sun is moving in the direction towards the south, that's called a descending node. Exactly the opposite when the sun is moving towards the north is called an ascending node. And there is a principle going on, a little sort of thing that happens to the Earth called the precession of the equinoxes. And what that means is that these nodes are moving through space. Right now, you see this place where those two lines come together at the head of Virgo. In the distant future, in hundreds and thousands of years, it will move through Leo the lion and up towards Cancer. When it started some 2,000 years ago or 3,000 years ago, it actually was in the constellation Libra. Libra, being the scales, was named because of those equal times a year. So the equinox being in the constellation, happening in the constellation Libra, kind of set into motion this whole idea about how the sun moves against the sky and about the meaningfulness of the constellations that we call the constellations of the zodiac and all of that. With precession over the last 2,500 years or so, that node, that particular place where it crosses, has moved through space and is processing through all of the constellations of the zodiac. Eventually, it will go all the way around. That's a cycle that takes over almost 26,000 years. It takes about 25,900 and something years for that precession of the nodes to complete one complete full cycle through the zodiac. So there's a lot going on there. And what does that mean to you? Almost nothing. You don't necessarily see the sun against those background stars. You're not marking the movement of the sun against stars in the background. That's not how we do it. The equinox still, to you, is the same geometry. That means that the sun sets exactly in the west on the day of the equinox. The sun is moving, its setting motion is moving towards the south every day after the equinox up until the middle of winter, where it stands still in the southern part of the sky for a little bit, and then sort of starts moving back again to the spring equinox. When it crosses the equator, it'll be exactly in the west again, and then start setting towards the north. It does mean some other things to it, and I just anecdotally, some of my friends have kind of come to me with some questions. One of them was my wife, and she says she noticed the light's different. And did I notice the light's different? The twilight's different. The things are around us have like a little different hue to it. And she's absolutely right, right? The angle of incidence of the sun towards the earth is changing. And this time of year, when we're right next to the equinoxes, it changes very fast. When we're near the solstices, the standstills, the change doesn't happen very fast. But at both sweeps of the equinox, we're losing almost 4 minutes a day of light. My brother-in-law said that he gets up in the morning very early, and he used to just go out and take a walk, and it was daylight. Now he has to wait and wait, kind of a half an hour or 45 minutes or so until it's light enough for him to walk. And he's noticed that that's moving very fast. The other thing we notice here in the city of Phoenix is we live in a city that has streets on a grid system. So you'll notice driving home at night or driving to work in the morning, if you're on one of those east-west laterals like Thomas or Indian School or Broadway or Baseline, you're going to sort of notice that that sun is actually in the way. It seems more obstructive this time of year than others, and that's because it sets exactly at the end of those streets and rises at the end of those streets as well. So it's a part of the year that we can actually see happening around us, and it's a part of the year where we can kind of just start to look forward to cooler days and when it gets to be wintertime. And I just want you to remember sort of what's happening in space is that this relentless movement of the sun against the background of stars is taking it past the equator and towards the southern part of our sky. And that all happens on Saturday, which is, trying to figure out, it's a Tuesday next week. Tuesday early morning will be the equinox. Mark that particular time. And that's the end of this little section. And I'm going to turn you back over to some questions and answers. Thank you, guys.
Awesome. Thank you, Rick. All right, going back to the polls, we're going to start polling, poll number 2. So poll number 2 says, what is the phase of the moon tonight? So new moon, waning crescent, dark moon, waxing crescent. So go ahead and cast your votes. And then number 2, have you gone out? Oops, I should launch the poll, sorry. There we go. Number 2, have you gone out and looked at Mars in the night sky recently? Yes or no? So go ahead and cast your votes, and I'm gonna turn things over to Alex while we wait for our answers.
Yes, so we have 2 questions that were asked. Jesse asked that he read that perihelion is shifting and that'll coincide with northern hemisphere summer. How hot will it be in our summer when perihelion is closer? So perihelion is the point in Earth's orbit when it's closest to the sun. So coincidentally, actually, or not coincidentally, but ironically, perihelion is actually one of the coldest global temperatures that we experience. We have a lot of water at the southern hemisphere. So at perihelion, a lot of the sun's heat is absorbed by that water. So overall, the Earth is a lot cooler. So actually, with perihelion being closer and closer to the northern hemisphere summer, there's not much change in temperature. The most change you'll see is maybe a couple degrees. Really, a lot of our temperature isn't impacted by our distance to the sun, but how much of that sunlight we're receiving on a day-to-day basis. So it's primarily influenced by the tilt of the Earth. And the second question is, Julia asked, how fast is the sun moving? So the sun is orbiting at about 828,000 kilometers per hour. And that's actually how it's orbiting around our galaxy. So our galaxy is all rotating kind of as one large disk, and the sun is part of that. Now, its rotational speed on its surface is different because the sun has different pockets of plasma and gases that are moving around on their own. So it's kind of more like a bubbling pot of water. There's no constant motion. There's all these changes between the equator and the poles. but it's moving around our galaxy very, very fast, and it's dragging all of us along with it. So now that those two questions are answered, I'll bring it back to Alicia and we can finish off that poll.
Thank you, Alex. Awesome. I'm going to end this poll. So question number 1 is, what is the phase of the moon tonight? And it looks like 49% of us got that right with new moon. So great job, guys. And then number 2, have you recently gone out and looked at Mars in the night sky? And most of us said yes, awesome. And I encourage the other 47% of us to get out there and look while you still can. So thank you so much, and we'll hand it back to Rick.
Unmute, turn on my video again. Thank you guys, that's really great. And so I'm going to do a little shout out for the person that said, no, I guess I'm not. Somebody answered, a couple of people answered waxing crescent, and that would be tomorrow night. That answer would be correct. Right now, since it's just actually a couple hours before a new moon, we might actually also say that it's a waning crescent today, but new moon is good enough. We're within 12 hours of the new moon, and I think that is a good answer, and I think that's good. So I'm going to actually do another thing here. So I mentioned it in the beginning. I'm going to turn the microphone and the screen back over to Spruthi, and what she has done for us is put together just a real quick little brief slideshow about the news about Venus, because that just hit the newspapers. I think it was 2 or 3 or 4 days ago, and I asked her to kind of just do a little review of it and talk about it before you guys tonight. So I'm going to turn it over to her. She'll share her screen, and we'll see what she has to say. Thanks.
Right, thanks, Rick. So I'm going to share my screen really quickly. We all know that Venus has been in the news for some days. I'm going to tell you why. Venus, as we all know, is a very hostile planet. It has an environment which is not inhabitable because of its extreme temperatures. Surface temperatures can rise up to 900 degrees Fahrenheit, and the air is drier and it's scorched than any place on the Earth. So all in all, it's a very uninhabitable planet. And it has a cloud cover which is made up of sulfuric acid. So the clouds are made up of sulfuric acid, but there's a band in the clouds, or a section in the clouds, where the environmental conditions are slightly moderate. So scientists believe that if they inspected that part, maybe they could find out a little more about the planet. And they did inspect that part, and what they found was traces of phosphine. Now, phosphine on the Earth is produced by microbial life living in oxygen-free environment. So on the Earth, we know that phosphine, which is a very rare gas, is produced by microbial life. But on Venus, if we found traces of phosphine, could that mean that there's microbial life present? Well, they did cancel out the possibilities of geological processes or lightning and volcanic eruptions. These kind of processes also do generate phosphine, but the amount that was found is not enough for, it was really more than what they expect out of a geological process. So this led the scientists to believe that one of the conclusions of this discovery is that life can possibly inhabit that band in Venus. So we are very close, or let's just hope that we are very close to discovering alien life. It still has to be confirmed. We don't for sure know that there's life on the planet, but this is a very good indicator that it could be possible that there's life on Venus. And the area of telescopes that was responsible for this discovery are ALMA, which is the Atacama Observatory in Chile, and the James Maxwell this thing in Hawaii. Okay, so two really huge radio telescope arrays were pointed at Venus, and together they found these signals and these discoveries. So I think this is a very great era for astronomy, and let's hope we find something awesome. So I'm going to give it back to Rick, and maybe you can go to the other news.
Thank you so much. I really appreciate that. It was just exactly concise and absolutely well stated. And so I like the way you put that together. Thank you very much. So when we were talking in our little practice session a couple of days ago, also the news hit, something new from the Hubble Space Telescope, which is absolutely amazing. And you guys probably saw that in the news and saw an outstanding image. I've asked Alex to look into that and sort of explain what's going on with that one as well. Thanks, Alex.
So I'll share that image right now. Let me pull it up. So this is an image recently taken by the Hubble Space Telescope, and this is of a globular cluster called NGC 1805. And this is kind of a early stage, smaller kind of galaxy object that is located near the large Magellanic Cloud. Now, most globular clusters are only one large population of star that were all born at the same time and will all die at the same time, but this one's unique because there are actually two distinct populations that are millions of years apart in age. So these redder stars are the older population, and these bluer stars are the younger ones that are formed more recently. Now, it's very unlikely that there are any planets in the system because of how close all the stars are together. They're about 100 to 1,000 times closer than the sun is to even our closest star. This cluster isn't visible in our night sky. It's on the southern hemisphere, so you'd have to travel down under to actually get to see it if you wanted to in the night sky. The blue stars in this image were taken using a combination of visible imaging and also ultraviolet, while the red stars were taken with a combination of visible and infrared. So these two populations will help astronomers better understand stellar evolution, including white dwarfs and supernovae, because you have two very distinct age groups that can be studied simultaneously and see how they interact and how they change at the same time. So again, these red ones are very old stars that we can understand more about the later evolution of stars. And these blue ones are younger ones that are just being born and have a lot of their life ahead of them. So by observing these two groups, we can see just a lot about how these different stars form and what might have caused this unique phenomenon in the first place. So I'll hand it back to Rick.
Thank you very much. Thank you, Alex. Excellent. And I don't know if people are following the history of the Hubble Space Telescope, but it is actually not being serviced anymore. It was in an orbit around the Earth about 340 miles above our Earth. It still is. And for a period of time, there were servicing missions where we could go up and fix it. We could go sort of like change gyros and adjust mirrors and things like that over time. A decision was made about 6 or 8 years ago just to not service it anymore. So it's starting to lose some of its aiming capability. It's starting to lose some of its functionality, but it just amazed me when I saw that image that it is still turning in such amazing images, and it's still producing such amazing science, even in its later life. And so good for us, good for the Hubble Space Telescope, and what a successful project that's been. We at the university are all looking forward to the next big, huge space telescope called the James Webb Telescope. And it will replace the Hubble in many ways with bigger light gathering power, a little bit more range. It'll be more sort of oriented towards the infrared so it can see deeper into space. And so we'll be looking forward to that, and we'll be kind of getting people up to speed on that, either virtually here or when you come to visit us on campus, because ASU has a part of the James Webb Telescope as well. Last thing I'm going to do tonight is just show you what we've sort of affectionately started calling this sort of planets not to scale, if you want to sort of look at it that way. And I kind of like that term a lot. So let me just sort of share that particular screen and you'll see what I mean. So what you're looking at here is the orbits of, and I've taken 4 of our planets and I've blown them up, really, really supersized them in space so we can actually sort of see a little bit about what's going on here. Remember when I was walking you around the night sky, and so you'll have to remember this, when we're going out tonight after the program and looking towards the south, you'll see a very, very bright Jupiter, and then right next to it, towards your left a little bit, will be a dimmer object, a little bit higher and a little bit further away. And that's Saturn. This is a sort of a little sort of depiction of what's actually going on in space. You can see the Earth there. You can even see that India and China are in daylight now. We are in the darkness. We are somewhere on the other side, the dark side of the Earth, and we're walking out to the edge of our driveway and looking out towards those planets. And they are towards the south, a little bit leaning towards the east. Towards the south. And Mars is just rising in the eastern part of the sky, just within the next 30 minutes or so. So you'll see it come up. And so what I wanted to show you here is a couple of things. First, if I can get this oriented just right, you'll see that Earth and Mars are very close together in their orbits. We call that time, that period where they pass each other, we call that opposition, and that will be happening pretty soon here. In fact, I'll advance the scene a little bit and you'll start to see. So the reason that Mars looks really super bright right now is because it's super close right now. You can sort of imagine they have two different cycles of their orbits, and about every 2 years and 7 weeks, that's the cycle, they come close together. The Earth is actually going to move in its orbit and lap Mars. It'll pass it just a little bit. And so Mars will continue to get brighter and brighter and brighter in the sky. It will continue to be earlier and earlier and earlier in your evening sky up until that time of opposition, which is in the middle of October. And then it will still be bright until after the first of the year. So it's an object that will be with us in the night sky for a while. But this is the observing moment. Start watching Mars now. I'm really pleased from the polls that you guys have been out there and checking it out. Absolutely, Mars is a super object to look for right now. I've only got a couple minutes left, and I just sort of wanted to show you sort of this is what's happening in space. This is why we see Jupiter and Saturn where they are in from our point of view, because that's where they are. If I were to take this and move it forward a little bit, I'm just going to go kind of forward like 2 months in time. I'll take 5 seconds to do that. You can see all these planets spinning like crazy. And then sort of readjust my scene. You can see here very clearly that Jupiter and Saturn have become even more close together. They're not getting further apart. So over the course of the next several months, when you're watching them, they'll still be prominent in the southern sky for a while. What I want you to start to do is start to notice that those two objects are getting just a little bit closer, a little bit closer, a little bit closer together. And then think about what's going on here. Think about sort of the conditions that are happening in space, what's happening with these objects in their orbits, and how we get to see them in the night sky, and how those two things relate to each other. Over the next couple of months, the Earth is going to move almost straight away from those two big planets. So they will get further away from us in the sky. And as we move around the sun, Jupiter is going to move towards the left in its orbit and start to sort of get in the way of Saturn. We will move around the sun and sort of make that condition even worse. They will never cross each other. By about the first weeks of December, we will kind of lose the whole scene in the sunlight. They'll set just as the same time the sun is setting, and so that we've only got a couple more months to observe Jupiter and Saturn. But it's a spectacular time to look at these planets. All three of them are putting on quite a show in the night sky, and the good news is that they will for the next couple of months, and that's where I'm going to kind of leave the astronomy part. We are back 2 weeks from now. So 2 Wednesdays from tonight. We'll actually sort of going to feature that particular evening. We're talking a lot about some citizen science. We're talking about some student programs where students get involved in the sciences through a special NASA program called the Space Grant internships. We're going to talk a little bit. I'm going to have a guest speaker that is a member of a NASA ambassadors. That is essentially a non-academic, just citizen that learns as much as they can about certain subject areas. In this particular case, he's a solar system ambassador. And we'll talk about what that means and how he got to be that way. We're also going to talk with a professor at ASU in 2 weeks about sort of the relationship between astronomy and the night sky, sort of, where they're the same or where they're not, where research is going, and how important it is for us to have a visibility of the night sky, and how that sort of helps our understanding of the meaning of space and the universe altogether. So that's all happening in 2 weeks. And then October is a really special month. Usually in October, we do a program every year called EC Day, Earth and Space Exploration Day. And that has been going on for 20 years. We're not going to do that on site this year. So we're working out some virtual solutions for this, but we're not going to ask people to sit at a Zoom screen for 6 hours and watch us do our EC Day. We're actually going to program a month of activities. So a couple of these evening shows. We also have a very special moment where we're going to grab some regolith off of an asteroid. We'll be able to watch that mission unfold. We're going to see some other things. We have some other activities planned for October. So October is going to be a big month. And we're going to share with you sort of the whole thing together. We're just going to call it Astronomy, Earth and Space Month. That'll be October, with lots and tons of different activities that go along with that. And so looking forward to that as well. I always appreciate the fact that we have well over 200 people visiting us now. And I hope you guys like this kind of programming, and I hope you like this sort of meet and greet we put together every other Wednesday night. And then just the reminder is, what you should do now is, because I'm about to sign off, let's sign off. Let's kind of get our computers put away. And then I really think you should walk outside. And I think you should look for some of the things we talked about tonight. Remember the tough one? You're going to look into the eastern part of the sky and see if you can trace out that square. That's going to be the one that's the hardest to find. The other's easy. Look straight up, you'll find the triangle. Look towards the west, you'll see Arcturus, a very bright orange star over there. Find those planets and make sure you sort of like are watching Jupiter and Saturn over the next couple of weeks. And so thank you very much. And we've hit the top of our hour, and I'm just going to say goodbye. Thank you everybody for joining us.